and over again.
Stereoplus er hos KEF for å se hvordan blant annet Blade blir laget. Det starter selvfølgelig hos utviklingsavdelingen. Husk å abonnere og trykke like for at vi skal dra på flere fabrikkbesøk som dette.
In the UK we do have a full design centre. A lot of the work is done on computers.
This is where we produce the 3D CAD from which our products are manufactured. So use a high-end 3D CAD system, and it allows us to produce high-quality component parts ready for our products. So here we have the CAD for LS60. If we take a little look inside, here we go. So we've got the cabinet and the drive units, the Unicore units and the UniQ, and the various trims that finish off the products. So all components, all mechanical components that go into our products all pass through the same 3D design process. Where the 3D CAD really pays off is with more complex parts that would be much harder to translate if we were doing this kind of work, the old-fashioned 2D drafting method.
What do you test with the 3D thing here?
In our case, it would be how it responds to mechanical forces, so vibration, changes in air pressure, that kind of thing. I would say that there are some things that we would have found it very hard to tackle without this kind of technology. So you look back at the products from 20, 25, 30 years ago, mostly rectilinear wooden boxes, because that was the best solution at the time.
This is the tweeter dome that you're looking at here. At low frequency, we can see that it moves like a piston, right? It moves up and down, but as we increase frequency beyond 40,000 Hertz, it stops behaving like a piston, and then its limited stiffness and its mass make it behave like an object that's not infinitely rigid, right? How do we know that we're designing a good tweeter? We connect that simulation, that FEA simulation, to a model of impedance based on the motor that we've designed for the tweeter. And then we correct for its mechanical characteristics by adding a little bit of stiffness and a little bit of damping. And then we can look that we've got a perfect match between our simulation and our measurement. Once we are sure that our drivers behave correctly, then we go and put them onto a system. And then we can simulate, build and measure that system.
You can build a speaker by doing this?
Correct. So we can essentially build a virtual speaker and look at its response before we build an actual prototype. And this allows us to go through many iterations.
There are some physical stuff here also.
Oh, absolutely. Yeah, there's a lot of physical stuff, because we have to, for every design we make, we could simulate everything, and we do to an extent, but it doesn't tell the whole story. It's never completely accurate. And then at the end of the day, listening is the final judgment. We have to make sure everything sounds good.
Since we are Norwegian, this is interesting.
Yep, we have a bit of a selection of amplifiers that we just sort of rotate.
So what do you think of the Norwegian amplifier? Is it better?
Oh, fantastic, absolutely fantastic.
You say that just because I'm Norwegian.
So we'll head to the anechoic chamber first. So this is the room where we make almost all of our measurements.
Inni her så er det helt dødt. Bare hør på hvor rar stemmen min høres ut. Det er ingen ekko i det hele tatt. Disse tingene her gjør at lyden er helt død. Det er slike ting i taket, det er slike ting på gulvet. Og det er sånn at man får litt sånn paranoia når man står her inne. Men hva trenger man et sånt rom til?
This is really where the majority of our measurement work takes place. We would put anything we want to measure in the center of the room, and we have an array of microphones around here. and we can rotate the speaker in place, so we can capture data from every angle around the speaker in 360 degrees. And we use this to model the off-axis performance as well as the on-axis performance. So we would play a frequency response or a frequency sweep through whatever device is here, and then using some maths we can convert that frequency sweep into a frequency response. So using that frequency response we can see things like how far the speaker goes down in the bass, whether there's any resonances, if there's diffraction problems, almost every quality we can analyse about a speaker.
Man lager altså konstruksjoner på data, og så bruker man da dette lyddøde rom her for å så vite litt grann mer om hvordan elementer og sånt nå spiller helt nøyaktig. Det er ikke alt datamaskiner kan gjøre ennå. When you close the door.
That was the next thing. So it sounds quite dead in here already, but if I close the door, be careful not to lock us in.
You don't hear anything here.
You don't hear anything at all. It's quite disconcerting. And with that, I think I'll open the door again. There we go.
And when you do the test, you do it here?
Yeah, so this is where we actually perform the measurements from. So when the speaker is doing the measurement, we don't actually sit in the chamber because that would affect the result. So we have everything set up outside. So we have a computer that we run our measurement sequences on. So we do that all from here. Into the transient room, the heaviest doors on site. So this is our transient room, which is almost the opposite of our anechoic chamber. So this room is meant to be a big, open, reflective space. In here, what you can do is you can measure a speaker, and then you can look at the impulse response of that measurement, and you can very clearly see where the reflections come from. And in doing so, you can effectively just ignore the reflections, which gives you perfect anechoic results. The only problem is you can only do measurements that are so long in time, which means that it limits your low frequency measurement. So in here we could probably measure to about 90 hertz, maybe 80 hertz. We put a hole in the wall up there. We can install a driver into that and have it radiate out across the surface of the wall. And we can use those measurements to capture just the raw driver, and that's a really useful development tool in the more early stages of product development.
How high is the ceiling here? How many meters?
I believe it's 8 meters. I could be wrong, but I think it's about 8 meters. It's a strange space. It's effectively like a squash court, but a bit bigger.
Det er i denne fabrikken her hvor høyttalerne lages helt ferdig. Kabinettene lages på en annen fabrikk i England, men her så monterer man den, man sjekker at høyttalerne er som de skal, og får de til å fungere best mulig. Det starter med å lage komponenter ferdig, delefilter og så videre, og teste de.
This is Carl, and he'll be doing tour of production.
I'll show you the process from start to finish. This is where we do all of the sub-assembly part. You can see here we produce terminal panels. So here is where we solder all of the components onto the terminal panels, all of the wires. And you see here Mel is putting wires onto the crossovers. The reference and blade, they're all pretty much assembled and handmade here, Maidstone factory. From all of the crossovers through to assembly of the cabinets, it's all handmade.
What are they doing here?
So we load in the reference into the system, and then we test the can and the crossovers against the reference sample. So you can hear it testing up through the range, and then on the screen here it tells us whether it's passed or failed.
So this is a good one.
That is a good one.
Så går vi til å montere alle elementer og finne ut av ting.
So we do what's known as cell building here. So one builder will build a speaker from start to finish, and their name will go on the certificate to show that person, that builder, has built that speaker. You can see here the wiring up the terminal panel, and then every speaker then gets fully tested here at the end of the line. We do 2 tests here. We do a sound test, a sweep test. So we listen to make sure that it all sounds correct, and then it goes into the chamber and gets tested against the reference. The results are logged, and as you can see, the speaker passed.
Selvfølgelig må høyttalerne bli helt fantastisk skinnende. Ja, disse er faktisk litt støvete. Men her blir pussefilla tatt fram, sånn at de skal være helt fantastiske.
Get the shiny.
Is it car polish?
Yeah. Makes it easy for the normal person to go up to and get some.
Yeah, so every process throughout the production line is a lot of hand building, a lot of human touch. Everything is handcrafted.
Det er faktisk sånn at høyttalerne blir filmet før de forlater fabrikken, sånn at det er en siste sjekk, sånn at alt er i orden, og man faktisk kan bevise det. Så er det inn i kassa, og så kommer det kanskje hjem til akkurat deg. Husk å trykke like og abonnere på vår kanal, slik at vi kan besøke flere fabrikker som dette.